is to build an OpenAI out of India. I have Rohan with me.
Hey guys, I'm Rohan. I handle everything at engineering. My title at Nimblebox is CTO, but like it's an early stage startup, so you know how things goes.
Perfect. The slides were perfect because the resolutions are a little bit off. But we want to talk about three main things, and then we can get into Q&A. First is our background. Second is the stack, technology stack that we have built over past 3 years. And a little bit more on research and how we actually are trying to do some really hardcore research out of India that has never been done before. So a background. First is why are we really here? We believe that chat is the new UI element of 21st century. Since 1990, since the birth of HTML, we really had the same basic things. We have a radio button, an input field, text area, checkbox, things like that. And for the first time, we have a complete new UI element that is going to change the way we talk to computers. In 2000 and 2010s, the main question was, the main level playing field moment was, should we have a desktop application or should we have an internet browser-based application? Now what we are seeing is, should we have a Photoshop with a chat interface or a chat interface that has a Photoshop built in? And that we believe is a very big level playing field thing. Third is that Gen AI really is a software and data problem. At the end of the day, it's just software. It's a bunch of Docker files, a bunch of artifacts that need to be managed. So what we did, that requires some credibility to talk here. So we built a chat interface out of India. We're the first ones to host Llama 2, and we have till date deployed over 50 LLMs. We have 350,000 threads across 51,000 users. So it's a multimodal chat app. It's fully feature-rich. It has a threads. You can share images in a chat. That is something you cannot do in OpenAI right now. And it can consume document, images, text, code, and audio will be adding soon. Document upload. This really is pretty cool. You can just upload your document and start asking it questions. And these screenshots were taken by me yesterday. I uploaded my COVID vaccine. I asked it, when is my vaccine due date? It is able to respond to that. And now I can have a full chat just based on a single document. We have an ever new models. We want to keep on adding more and more models into our ecosystem. And more importantly, someone mentioned that they use LangChain in production. Very unheard of statement, but we actually figured out how to productionize chains. We built an entire open source engine called Chain Fury, and we can now start adding features to our chat interface that are not really possible inside OpenAI ChatGPT right now. So to talk more about the stack.
Yeah, so coming to what our talk is actually about, it's about deploying LLMs and benchmarking that. We internally really compare ourselves to OpenAI. We believe that we can be the first OpenAI out of India. There will be many more in future, but we do believe that we'll be the first. We support a lot of clouds. Like if you attended the Gen AI Flipkart talk, you will realize that he mentioned that MLOps layer is like one of the most backbone of whatever you're developing in Gen AI. And before we started ChatMBX, we were actually a MLOps company. We were able to host a lot of different models, including Whisper, Flan, and everything. As soon as Llama 2 was launched, like Yash mentioned, we had we were one of the first ones to host it. This is what our stack internally looks like. We run on any cloud provider. It can be AWS, it can be Azure, it can be whatever you choose. We have a MLOps layer, which is actual Nimblebox core. This is what we have built in past 4 years. And finally, we have the application layer. Application layer is something similar to what you see on ChatGPT. We have ChatNBX, which is the chat app. We have Studio, where you can actually go there and do playground-related things. You can create agents, you can access APIs, and you can also fine-tune modules. So, yeah, how to deploy modules, right? Like, that's the major question. Like, if you have attended all the talks, you might be coming to here, like, can I deploy this model internally? Can I have it hosted in my cloud? Can I have it running on my machine, maybe? So, first question, from my perspective to solve is, what inference server, what module server do you want, right? Like it can be open source, or you can build it in-house. If you're building it in-house, there's a lot of research work which you'll have to do. You'll have to look into libraries like flash retention, you'll have to look into things like quantization, and a lot of different things. If you're going with the open source offering, we have multiple which are already there. We have TGI, we have VLLM, we have Triton. You can just like choose one of them. Once you have chosen the inference server, the next thing you need to decide is the real, like while deploying them, there's like a lot of optimizations you can do. You can quantize them, which reduces the size by 75% without having a major accuracy hit. Quantization really depends on what data you're quantizing on. It cannot be just a random text, wiki text, which other people do. And one thing which we have talked a lot about, and one thing which people believe OpenAI has advantage is context length. Their GPT-4 module is able to handle up to 200K context length, and you can achieve that in open source also. It's not a very tough thing. You just have to implement something called rope. A lot of these open source inference server already support it. And what it is rotary positional embedding. There's like a lot of research paper on it. There's another method called yarn, which is yet another rotary positional embedding. And yeah, like a bunch of research which you'll have to do. And finally comes scaling, where to deploy these modules. Like you can't just go and deploy this on a CPU machine with some RAM. You need to understand what these things runs on and what's the best hardware you can deploy them on. A general rule of thumb is you need 2 times the amount of VRAM than number of parameter. If you want to deploy a Llama to 7B, you need at least 14 GB VRAM.
One thing to add here is that the inference time magic, just like in software 1.0, you wrote code in C, and then you compile it to a binary. In JavaScript, you write a particular application, you run it as yarn run dev, and then you compile it into a much smaller binary, and then ship it over the web. This is really same kind of parallels, where this is just, inference time magic really is how can I compile my existing model to make it run faster, maybe take some hit on the performance, but still make it run faster and be more efficient during runtime.
Yep.
So yeah, I mean, there's a lot of different companies and models that have come out because of this entire space. By the way, all of these models that you see here, we have it running on our chat application. I think everyone has explained over the entire day why should they use it, but the way we see it is 5 main reasons. First is it solves security concerns. When you have the control of the model, the inputs and the outputs, and it is running in your cloud, that's the maximum level of safety you can get. In full honesty, these models are 3 months behind the closed source models. But again, a lot of the things that are being achieved by closed source model are low-hanging fruits. Once those are done, the delta between closed source and open source won't be that high. Third is modification of behavior, or in software 1.0 terms, it's a forking of the weights. I take an existing weight, I add my data to it, and I get something new out of it. Maybe if someone, one very simple example that Twitter did with Accel AI was that if you try to ask it a very inappropriate question, it responds back sarcastically. Just having that simple thing makes the brand feel much better. That, okay, instead of a very dry saying, I am an LLM trained by Meta AI, I'm not allowed to say XYZ. If you can say, bro, what are you, a 15-year-old? If you can just respond back a little bit more sarcastically, it adds a certain brand value and flavor to it. Fourth is generous commercial licenses. A lot of these models released by organizations have really good commercial licenses. You should not be worried about using them. And fifth is all modalities. You have to think about saying that this AI is going to do what a human can do. So it can see, it can read, it can consume document videos at a rate that is, say, 100 humans per second kind of a thing. So it should be able to consume all modalities.
Yeah, so as you can see, we have deployed over 70 modules in past 3 months of having Chat NBX online. We have seen a huge user growth. We see that a lot of people prefer news Hermes variants of Llama 2 13B, mainly because it compares really well with ChatGPT 3.5. You also see that this Llama 13B, the base model which was released by Meta themselves. You see there's Open Assistant, there is a lot of different variants. If you want to go with any of them, I really recommend go with News Hermes to try things out. If it works out, then I suggest you fine-tune on your own. Fine-tuning these things are very easy.
Perfect. Next slide is the same model usage done over time. And you can see exactly around September when the model usage dropped, that is when we monetized our platform. So the important thing here to note is the capacity that the system has been able to handle and what it is handling right now is, the capacity that the system is handling right now is less than what it is capable of. And what that means is if you can simply throw more load at it, it will work successfully. Now that is one of the first pillars of our operation. As I mentioned that we want to build an OpenAI equivalent company out of India, and we should be able to handle that kind of a load and scale. And this is in many ways a demonstration of that. By the way, the GPTs, we started calculating usage for open source models much later. So that is why the data is a little bit shifted.
Cool. So coming back to what deployment inference server to use, we have done a lot of testing. It really depends. I really recommend you benchmark it internally. What you see is the numbers for a Llama 7B running on a E10 E100 with input token as 100 tokens and output as 500 tokens. We ensure that it always generates 500 tokens. In real case scenarios, you won't see that. If you have a chat app, you'll see maximum 100 tokens, on average maybe 250 tokens being generated. Second thing you should be aware of while benchmarking is, like you can see there are 250 percentile to 95 percentile. First we tested it with one concurrent request, second we tested it with 16 because these large language models are really difficult to benchmark because each API is responding within 7 seconds depending how much output you're generating. They're responding 10 to 15 seconds. But testing them concurrently is very important, especially testing them, say, 16 concurrent user, 32 concurrent user, or maybe even more. And as you can see, your latency actually goes up. There's a very easy way to resolve this. You can just add more VRAM to it. Adding more VRAM, adding more GPUs really brings all of this down.
Perfect. Next, I want to talk a little bit more about research and why is that important? Because India in general has not been considered our products are not really considered that great in the world. Let's be honest about it. And the reason is that they are not very well researched products. Usually these are first copies or generic versions of things that have already existed. We need and want to build something great out of India. So how did the entire research organization or the process inside our company start? In many ways, a lot of companies that you will be joining or are here, you will be setting up something similar down the line, maybe a year down the line. But I think you can take some learnings from this. So we started because we had a lot of chat data. And we, at some point, reached 50,000 chats, and we really could no longer analyze all of them. Initially, if there was some kind of feedback, we could actually manually go read the messages, things like that, but it became really impossible. So we did a lot of analysis on, all kinds of conversations. What are they talking about? What are the languages? What are the topics they want to discuss? So for example, if they want to write stories versus they want to write a code, are they producing long content versus are they producing short content? In fact, one of the most interesting things that we found here was that we could identify corruption in data sets. So there was some kind of a bug during our SQL query, and we corrupted our data set, and we were able to identify a corrupted data set directly via using an LLM. And as far as we are aware, we are one of the first ones who have been able to do that. The one thing that everyone should take away, and the research team really is driven on this entire principle, is the bitter lesson. This was given by Dr. Richard Sutton. He's essentially the father of RL in many ways, wrote one of the most influential books. He said that the bitter lesson is that 70 years of research has shown that methods that leverage computation are ultimately the most effective and by a large margin. Can I get a raise of hands? How many here play chess? Okay, a few people play chess. Now tell me one very simple thing. If I put all of you against a single computer, do you think you'll be able to win it? Yes, no, no. That is because a very simple algorithm, simply thrown at 1,000 servers, will be able to outperform every human. That is the truth. That is the bottom line. So in many ways, computation is the single most important element in this entire equation. The more computers we have, the better we'll be. As simple as that. And that is why you hear Ilya Sutskever saying that there will be data farms powered by solar energy and whatnot. That is because it is true. You need to have data centers the size of football fields, data centers in the middle of cities, data centers in every village to be actually able to run and build AI that is going to transform India. So how did we do it? We trained over 100 LLMs and did over 100,000 production API calls. You know, we don't hide a lot of things. We directly train the model, put it on production, test it on APIs. We just test in live. There's no extra evaluation steps and things like that. So it started in August when we really just wanted to, again, just check the chat data, how it was going. And we built some basic baselines out of it, just to know that, okay, humans in general prefer this. So if our models, when we want to test it, is it as good as that or not? Second, in September, we were almost done with Tune Studio. And so Rohan asked me that, you know, we want to stress test the system. So we trained 54 LLMs in less than 20 hours. And by the way, fine-tuning is expensive is a myth. Fine-tuning runs for 20 minutes, 30 minutes, an hour max. It's the inference, which is running 24/7, which is way more expensive. So fine-tuning is cheap as hell. We did 20,000 API calls on production for 4 tests. This is very important. The benchmarking has to be done on individual test. What we learned was you can have one test with 100 samples, but if it is good on 3, it generally is good on rest 97. So in the next version, we changed it. We did 660 small tests. This is everything from JSON output, how good is it at summarization, how good is it at transliteration, translation, all the Indic languages. As a pet peeve, we focus a lot on Sanskrit as well. And we built really 3 bespoke data sets by scraping the internet. So this is where we were as of a couple of weeks ago. What we have done is now we are entering from an experimental stage to a production stage of research, where we are now building RLHF data sets, because reinforcement learning really is the future. Until now, it was really hardcore. It is no longer that hardcore. I think we have cracked it. We know how to make it much more simpler now. So building a RLHF data set, ranker model, and we have started doing multimodality. We no longer want to limit ourselves to text. When we give our data annotators problem, we give them everything from, hey, here's a PDF, can you read it out? Here's a PDF, can you summarize it? Here's a PDF and another PDF, can you create a common Excel sheet out of it? So reason being that we need to do all the modalities everywhere all at once. During this phase, we are also setting up a data annotation team, and we are also setting up a team for red teaming essentially, that whatever models we release, we want to have good checks and balances in place for that. Next, what we are aiming for in next quarter is to achieve full stack integration. Right now, we use a lot of open source tools for training, for inference, and across the entire stack. What we want to do is have the entire thing as our own. Next, something that we're looking at is personalized ranker models. This is something that OpenAI can work on, they haven't. But really is, why should AI be generic? Why should ChatGPT for you be same? It should be personalized to everyone. Just how Google search is personalized for everyone. Just how YouTube is personalized for everyone. Just like that, chat interfaces and AI will be personalized. It's just a question of how and when. So with that kind of a vision also, we have started to work in that direction. And just one more point, like this is a product stack. So Tune Chat NBX sits on top. The Tune Studio that Rohan covered, which has a UI as well as an API for fine-tuning agents, monitoring, artifact storage, all of that. At the core is NBX Core. We actually built an entire equivalent stack inside our organization. And as far as we are aware, a lot of companies don't do it. A lot of companies treat the production data, a production stack as the only thing that they have. That is not how it should be treated. You should not be afraid to write 10 times more code, honestly. It's not that much effort. And as Karthik covered, we have GitHub Copilot now. And we have actually open sourced a lot of things that we built internally as well. Chain Fury right now, it is in production. A lot of our software that we, things that we built on uses Chain Fury. So yeah, I mean, in summary, research stack is something that we entirely built in-house.
So finally, coming on back to the talk, deploying and benchmarking, right? How do you go about it? What model to choose? How do you start building a POC, making it production, and taking it to the next step? To start with, if you're in a POC stage, I recommend using APIs, using GPT-4 APIs, using Llama 270B APIs from any of the vendors, or using our platform. Once you're done building POC, you will come to a point where you have to figure out whether speed is more important or accuracy. You might be ready to lose a bit of accuracy to get 10 times more speed, and that's really possible. That's when you start experimenting with smaller models. You start having private models. Private models also help you with privacy concern. It helps you fine-tune them, collect data, and a bunch of other things. And finally, coming to fine-tuning.
So, as we go, larger is better. The idea really is how much investment you want to make. We understand that, companies don't want to immediately spend 100K on something that they do not understand. But you can get a lot out of $1,000, and for, everyone's at the Accel Summit here, so I'm sure everyone can spend $1,000. It, in the end, really comes to fine-tuning data set. The magic really is that once you have focused on all these three things, as we have, the stack really goes into the background. We no longer think about it because it is something, it just works. And then what we start focusing on is the data sets. What is the minimum number of examples I need to get to a certain performance? And that is really, really the place where you want to be. So in practice, you should cover these three as fast as you can, go through them in 3 months, experiment a lot, and then immediately switch your gears and start building data sets. So yeah, thank you very much. If you have any questions, we'd love to answer those.
Please raise your hand should you have any questions or queries. We'll have a mic handed to you. The same drill proceeds. You can follow it up with your question or query.
Okay. Cool, I guess. Well.
We do have one question. Cannot complete the session at least with one question, is it not?
So all of this is great, but what do you think happens in 5 years?
In 5 years, it's really, no one knows. In many ways, first is all the models will be multimodal. There is not going to be any LLM, or it's not going to be a SDXL. All models can consume all modalities, will be able to generate all modalities. Their ability to remember is going to be practically infinite. They'll be able to remember everything, everywhere at light speed. I mean, who knows? Like, for all it matters, there might be some robot with a, touch or some kind of modality. Who knows? Yeah.
So the mic behind you? There's a mic behind you. If you could use the mic, please.
You mentioned 54 LLMs around. I don't understand. What do you mean? How do you distinguish one LLM from other? I thought only ChatGPT or Hugging Face one LLM. What do you mean by many LLMs? Not clear.
Got it. So when we say an LLM, it really means a very big binary file. This is about like a 7 GB binary file that contains the model weights. It's just a very long row of numbers, honestly. So whenever we train it, we change those numbers little by little.
Okay. So it's just for one set of training. Okay, you have say 1 billion sentences. You train using, let's say, another 500 million weights. So that is one LLM. Okay,
Yeah. So you have a big row of numbers, which is your LLM. You take a little mix of data, you add to it, you get one more LLM, you train another, you get another.
Okay.
Perfect. Any more questions? I think there's one question at the back.
We'll take one last question at the back over here. So if you could keep your hand raised so that my associate can find you. So.
For user personalization, are you guys looking into private computation of some sort, say fully homomorphic encryption or something else?
Not really, not right now. See, we are not trying to reinvent the wheel entirely. We want to reinvent the pieces that we know we can do better. So the way a lot of personalization right now works is via something called session embedding, where if you think, for example, Bing search, whatever is your past queries, it takes an embedding from that. Your user, as a user, what are your past queries as an embedding of that, and whatever you are asking right now, an embedding of that. And that is how it generates the next token. So it's pretty straightforward right now. Perfect.
Thank you,
Well,
sir, for your
thank you so
questions.
much.
Thank you, Rohan. Thank you, Yash, for taking the time of joining us out here at Accel AI Summit and for sharing with us your knowledge. A round of applause. And now for the concluding remarks, once again, let's welcome on stage Mr. Priyank.
Thanks, guys. Thanks for all of you who are still here, 5:30 in Bangalore evening. Thank you all for coming. I hope this was a useful summit for all of you. Just show of hands. You guys found it useful? All right. It's